All right, it's high time we started. And as usual, I would like to start with a selfie. So wave, smile, whatever you like. Great, thank you. Good morning, everyone. I'm really happy to be here at Devoxx Poland in Krakow, and it's wonderful to see you all here in the room. I would like to start this presentation with a question. Did you know that business process management market is currently worth around $8 billion? And I can tell you even more. By 2025, it will be worth around $18.5 billion. Why would companies invest such incredibly huge amount of money into BPMS? And the answer is simple. Because these are business processes that define how our companies make money, how they are competitive, or simply how they live in the complex world of legal regulations. Wherever we come from, our companies are pretty much the same. They want to earn money and reduce their costs. And that's why they try to identify, analyze, optimize, and automate their business processes. And they often do it just by buying an off-the-shelf solution, a ready product. And there's completely nothing wrong about this. At the same time, though, we developers are often used to follow agile software development principles. We know how to utilize domain-driven design, microservices, to deliver products of high quality and deliver them much quicker. The question now is, how can we reconcile business process management systems with the idea of microservices and agile software development? And during this presentation, we'll try to find the answer to this question. We also see how tools from Spring ecosystem can help us achieving this goal. And we won't dig too deep into technical details of these tools. We will try to keep this presentation on a high level so that we all get the idea and understand the approach that we can take in order to find the solution. My name is Bartłomiej Słota, and I come here to you from Warsaw, Poland. And I also come here as a person that spent around 4 years automating business processes. I've been there. I've walked through the good and through the bad sides of these kinds of systems. Currently, I'm a consultant at Bottega IT Minds, and with the consent of our client, I can briefly tell you about what I'm doing professionally today. I currently work for Vattenfall, which is a Swedish power company whose mission is fossil-free in one generation. And Vattenfall is also e-mobility services, including charging stations for Tesla and other electric vehicles. And of course, web services for users. Within the last few years, the cooperation between Bottega IT Minds and Vattenfall IT Services in Katowice, Poland, resulted in a 5-time increase in the number of available charging stations. And today, we're in the progress of migrating the old e-mobility platform into new microservice environment, running on Kubernetes clusters in Microsoft Azure Cloud, and tools that we used on a daily basis include Java 11, Spring Boot, Apache Kafka, and many, many more. Before we get into the core of the presentation, let's meet Bruce, who is a software engineer with like 7 years of experience. He's been working on automating business processes for quite some time already. And Bruce is also very passionate about microservices. He reads books, he goes to conferences, just as we all do. And you know what? Bruce struggles a lot in his project, in his company. There's a lot of frustration going on. People are quitting the company. It's very hard to communicate with business people. It is hard to produce any single change in the system. It is even very hard to find a line in the code that should be modified in order to provide this change. And Bruce feels that microservices can help him, his project, and his company. But he has no idea how to apply microservices into BPMS. So during this presentation, we will try to help Bruce out. And before we do so, we need to know what microservices are all about and what BPMS are all about in order to be able to find some solution. If you ask Bruce what microservices mean to him, he would tell you something that I told him like hundreds of times before. Microservices are all about the autonomy. What is the autonomy? Autonomy is a vector consisting of 6 dimensions. The most important one is scalability. We may scale our services for numerous reasons. We need to deal with a bigger load, the traffic is getting higher, then we may either scale our services vertically, just by adding new resources like CPU or memory, or we may scale them horizontally by adding new instances of our services. Yet another reason for scalability is that we want to stay resilient in case of failure. And then vertical scalability won't give us much, and we would rather go for horizontal scaling. But what I'm trying to tell you now is that scalability is not only about technical stuff. Application in its lifetime may get to the moment when the size, the complexity, the technical depth might get to such high level that the system won't be scalable from code perspective, architecture perspective, and even organizational perspective. And such example is very well described by Uncle Bob in his book entitled Clean Architecture, where he actually describes the real-life company, and he describes how things changed from iteration to iteration. And what you can see on the first figure, on the top left, is that the number of engineers required to maintain and develop the product, release by release, is drastically rising. At the same time, the number of business lines of code that are being written iteration by iteration is falling down, which in turn means that the unit cost of a single business line of code is getting higher and higher. The more people we have, the least code we write, the lower the productivity is. And what our CEO sees now is that our IT department no longer costs like $1 million per year, and now it costs like $20 million. So you can see how crucial it is to take care of organizational scalability as well. And getting back to the autonomy, each part of our system should be independently scalable, just as our organization does. And here's Bruce. They are struggling a lot. It's very hard to produce a slightest change. It is very costly to write a single business line of code. There's a lot of frustration. It's hard to communicate with business. The code is messy. So we need to help out Bruce in this area as well. Second dimension of microservice autonomy is deployment. The way each microservice is being deployed should be an individual decision of a team that is responsible for this microservice. Of course, we may aim to have like consistent deployment schemes throughout the company, throughout all teams, but still there might be components, or there might be components like ACLs, anti-corruption layers, or components that are working under strict legal regulations that follow some unique software development life cycles. Anyway, how to provide deployment autonomy? We need to make our services as independent as possible. How to provide independence then? Through high cohesion, which in a nutshell means that our services, the logic they contain, must be concentrated on concrete business functionality. Microservices are not only about the code. These are databases as well. Each microservice should manage the data that is responsible for itself, securing the access to data, securing the access to database schema, so that no other service can access it and modify it. Yet another autonomy vector is technology. Dividing our business into parts, let us choose technologies that are appropriate for the complexity of the problem that we are currently solving. So we may use a different set of technologies for a part of our business that is very complex, and different set of technologies for CRUD applications, where we might use, for example, Spring Data REST. We might also experiment with new technologies and solutions, not impacting the whole system. And with these experimentations, we may be more competitive on the market. In the world of distributed systems, failures are inevitable. They will happen. Why would a counting module failure block the possibility for me to read the charging sessions of my Tesla? The autonomy is the autonomy of failure as well. So the failure of a single service should impact other services in the smallest possible extent. And finally, nothing would have happened if it hadn't been for people. Microservices can only work in companies, in places where organizational culture is ready to give teams the autonomy to let the teams to take care of the product end to end from the very beginning, from the very first analysis, from the very first talks with stakeholders throughout the whole life cycle. They need to let the leadership to show up itself in teams. There is no place for command and control. how many times were you angry about how things communicate within your system, how components communicate with each other? Too often, probably, right? And it doesn't happen just like that. According to Conway's law, the man from the image over here, is that every organization will eventually create a system that mirrors communication schemes from within the company. And we developers often tend to ignore business. And do you know what happens with this ignorance? It is coded, committed, and pushed to Git. What can we do instead? Instead, we should talk with these people, cooperate closely with them, because only when we are on the same page, we use the same language, and we have common understanding about how business really works, only then we can work around true business bounded contexts, and thus create really, truly autonomous microservices. And that's why we should advise Bruce to start with event storming. Event storming is a workshop-based method of exploring complex business domains, business processes, proposed in 2013 by Alberto Brandolini. And event storming is incredibly engaging, powerful, it is very easy, and fun as well. And big picture event storming, which is one of the possible variations of this kind of workshops, is usually attended by people from different areas. There might be stakeholders, analysts, product owners, developers, architects, quality assurance engineers, whoever who can have some insights into the problem that we are working on. And leaving the room, every participant has the same level of knowledge. We all know how the business flow looks like. We know where we gain money, where we lose money, where we gain reputation, where we lose reputation, where are the pain points, where are the hotspots in our systems. And finally, we start using the same language with business people. And it also gives us the base for further work, like design-level tactical sessions, where we actually get the meat for us, for developers, the aggregates, entities, and all domain-driven design building blocks. Why are we talking about event storming in terms of business processes? In every organization, people tend to do two things. Do their job well, which is naturally good, and ignore what happens around them, outside the team or department. And as we already mentioned, this ignorance can be very dangerous, as we may lose the big picture of how things communicate, of how things influence each other. And this is how silos are born. And business in every organization, in mine, yours, and yours there in the back, is the same. And it's never restricted to one type of operation in one silo only. Business always crosses silos, always. It means that there's no single point of truth when it comes to understanding the whole big picture of our business process. And it's also a source of confusion, because because people from one department might use different definitions of the same term than people from the other department. That's why the business problem is hard to solve, hard to discuss, and hard to visualize. And it's the event storming that enables us to overcome all these obstacles. And then we can find the common vision with the business, start communicating with them, not using any UML or BPMN diagrams provided by some proxy analysts or proxy product owners. It is a living well, a living source of knowledge. And similarly, business process implementations might cross different microservices owned by different teams, so they will need to communicate somehow. And Bruce really knows that he needs to start in here. He really, in order to understand the mess he has in the code and to understand what the system is currently doing and what it is supposed to be doing. But still, Bruce has no idea how to apply these microservices into BPMS. So let's try to find out what BPMS are all about. And here what we can see is the high-level overview of almost every business process management system. Of course, there might be some other components, but let's keep it simple. In the heart of every business process management system, there's a thing called workflow engine, which can be treated as a black box that is responsible for business process execution, including human task execution, service task execution, access control, process metadata management, and many, many more. But what the business is really looking for are those fancy UIs. They buy with their eyes, right? They want to have consistent views, user-friendly views, because they want their work to be easier. What they also are looking for are reports. We all need to know how our processes are performing, if we are doing well or not, if we are earning money or if we are losing money. Looking at all those reports and stats, we make decisions what to do with our business next. And we may also have some process modelers where we can model our process in some standard notation like BPMN or something. We may also have some system integration, some connectors so that we can connect our BPMS with already existing infrastructure. And this is kind of a high-level overview. How does it look like from architectural perspective? It is usually a monolith. And user interacts with BPMS through some fancy UIs, and he ends up in a component, let's call it a UA controller. What UA controller does is that it passes requests to modules like history, reporting, user and access management, human tasks, task lists, and all task-related stuff ends up in the workflow engine. And each of these components use the same, usually relational, database to persist the state, to persist data. The question now is, does this architecture apply to the autonomy we've been talking about? Let's try to find out. Do we have scalability autonomy? No, we don't, because we either scale the whole system or we don't scale at all. So we don't have scalability autonomy. Do we have technological autonomy? We don't, because we are restricted to use the same set of technologies in every business process. Do we have deployment autonomy? We don't. We either deploy the whole system or we deploy nothing. Actually, I know one commercial system that supports individual separate deployments, but still underneath, there's the same set of resources. So if anything goes wrong during deployment, we either get deployment autonomy, no resilience autonomy. Do we have data autonomy? We don't, because every business process uses the same physical database, the same generic schema, and it's even very hard to distinguish lines in the table and assign them to a particular business process. And finally, teams. They're working usually on common code bases. They schedule deployment. They need to merge their changes. So this kind of systems usually do not apply to the core idea of microservice autonomy. And this is the point where Bruce gets so confused, because he wanted to apply microservices into BPMS. And how Bruce, as developer, might perceive it? Well, he's sad not only because this architecture does not apply to the core idea of microservices, but he's also sad because his work is very often manual. He needs to click through some crazy management consoles in order to produce some, to generate some form or create a data model or whatever. And he's also technologically constrained. He cannot bump up the Java version from 7 to 8. But he started, as we advised him, with event storming. He invited his colleagues, and they ran a quick workshop and analyzed one of the processes that exists in their company. And the process is called address change. Let's have a look at how it works. Whenever the customer calls the call center and requests the address change, the call center employee tries to attempts the authorization. And then customer is obliged to provide some customer password, something. And if this password is correct, address change is authorized, and we register the address change. Then is the moment when anti-money laundering process gets started. And if the AML check is positive, we confirm the address change. And if it's not, we recall it. And because Bruce is very fluent in BPMN, he quickly sketched a diagram that corresponds to what we model with sticky notes, with the difference that it might not be readable for everyone. Because in order to understand it, we usually need to know BPMN, which is the opposite to the model that landed on the wall that we created during event storming. Because these are just sticky notes written with a pen by a human, right? Bruce made also enough analysis to assume that there will be 3 microservices. Authorizer, which will be used by most of business processes, customer contact, which is responsible for managing customer contact information, and AML for anti-money laundering related processes. These services communicate somehow. And regarding communication, there are numerous communication patterns that might be even mixed within one company, but from now on, we'll focus on asynchronous communication only, as we want our services to be as decoupled as possible. What asynchronous options do we have then? The first one is choreography. Choreography assumes that there's no central point in the system that actually makes the decision where to send every message, where to route every message, and decide what is the route. Instead, services emit event messages and don't care about what happens next. On the other hand, consumers read those messages and take further actions. Choreography, in our case, would look like this. Client requests the address change. We will analyze only the successful path, okay? And the authorizer reads the address change requested event and emits address change authorized. This event is in turn consumed by customer contact, which responds with address change registered. Address change registered is consumed by AML. AML responds with AML check succeeded. This, again, is consumed by customer contact. And finally, the address change confirmed event gets back to the client. In general, choreography is a great way of communication between services. In our case, in case of business processes, we might identify a couple of problems, though. What are those problems? Well, if we have a look at the authorization service, it listens to address change requested event, which is a process-specific event. So anytime we want to add a new business process, we would need to modify authorizer, right? And clearly, hypothetically, one could say that, all right, why don't we introduce some generic event like authorization requested? And I would say, in general, the idea of the event message is that the event must mean something to business. Does authorization requested mean something to business? I don't know, and I'm not sure. Another thing vital in the event messages is that if we emit event message, we don't care about what happens next. And here we care, because we either accept the authorization or we recall it. And what's more, we want one particular service to get the message and not the other one. And what's more, it is also an imperative. So it would be wrong usage of event message pattern. And instead, it should be a command message. Yet another problem that we may spot in here is that customer contact, it needs to know that it communicates with AML service, because he needs to listen to AML check succeeded event and AML check failed event as well. So anytime we need to change the order of steps in our business process, we need to modify both of these services. Do we have any alternative to choreography then? We do, orchestration, which is nothing more than just event command transformation pattern. This is how it works. Now in our web sequence diagram, there's a new actor called address change process, which is a business process orchestrator. The role of the process orchestrator is to read events and take further actions with sending commands. In our case, whenever a client requests address change, the address change process orchestrator sends a command to authorizer through message bus, authorize address change, which in turn emits the event address change authorized. This event is consumed by our orchestrator that makes the decision to send the command to customer contact emits the event, and again, we send the command to AML, etc., etc. And finally, the address change event gets sent back to the client. Do you know what Bruce asked me? Why don't we join the address change process orchestrator with customer contact service, as they have similar business responsibility? Can we join them? And the answer is yes, we can. According to hexagonal architecture, the business logic should be independent from application and infrastructure layers that are part of the address change process orchestrator. And it would be even simpler to find the owner of the process, because it would be just one consistent application. And why did we do it like this, where we have it split? Because it is not always that simple that we can map our business process orchestrator with a business service one-to-one. How do we know if it's possible to join the orchestrator with the business service? And if we do know, with which one? And this should be available to us after event storming, and we will get back to it soon. Yet another question from Bruce. What if anything goes wrong within the AML? Because if AML check fails, or there's any error, we already registered the address change. We need to store the state somehow in the address change process, right? And the answer is not necessarily, because we could go for routing slip pattern and send the following instructions in message headers, for example. But clearly, practically and pragmatically, we would rather go for process manager pattern or saga pattern. And this is exactly what we just modeled here. Whenever the address change is registered, we start the transaction. When the LML check is positive, the address change gets confirmed, committed, or where the AML check is negative, the address change is recalled, rolled back. And regarding the implementation of Process Orchestrator, we have numerous options. We may use simple if-else statement. We may use finished state machine. We may use actor model. We may use even activity and store our state in relational database. There are plenty of possibilities. How does it look like from architectural perspective? On this C4 diagram, the green components are common for every business process, and they correspond, and each box corresponds to separate microservice. It begins pretty similarly to what we've seen with BPMS already. User interacts with the system through some fancy UIs and ends up in the UA controller. What UA controller does is that it forwards commands through Apache Kafka to address change process orchestrator, or forwards requests to common components like reports, task list, history, user, and access manager. And all these common components, they listen to events emitted by process orchestrators. And based on these events, they produce read models for UA controller to present them to the user. Doesn't it sound like CQRS? It is CQRS. We send command to the process orchestrator that emits events. Events are consumed by these components that create query models for our users. This is CQRS. Interesting is also the component on the right, user and access manager, that was used to be the part of the workflow engine. And here, it is separate from the process orchestrator. Why is it so? Because the process orchestrator doesn't care about the implementation of the authorization engine, right? The only thing he cares about is the user and its roles. What happens next is that the address change process orchestrator sends commands further into authorizer, customer contact, or AML, and it listens to events emitted by them to Kafka topics. And each of these microservices manage data itself in its own database with its own schema. And Bruce knows, we mentioned Kafka. Bruce knows Kafka a lot. He knows its performance stat, all its advantages, but he wonders why it could be helpful for us here to use Apache Kafka. And we could find at least 3 reasons for this. First of all, consumer groups. It means that process manager can listen to events emitted by business microservices, not competing with any other service for accessing this event. What's more, it won't interrupt the choreography that might be happening somewhere here. That's the first thing. The second thing is scalability, backed by topic partitioning. So we have like 10 partitions per topic. We may have up to 10 instances of our process orchestrator. And finally, Kafka Streams, which is a fantastic tool for building streams and views, and we will get back to Kafka Streams as well in a second. Okay, Bruce has another question. How can we deliver new business process? Do we always need to modify all these common components? If we would need to modify common components every time we introduce new business process, it would rather be a distributed monolith than microservices. What can we do instead? The answer is use convention over configuration. What I mean by this is that we could establish a set of generic events that will inform us of every possible change that may occur in our business process instances. To be more specific, I'll give you some examples. Process instance created, process instance canceled, task created, task completed, task assigned, and many, many more. And what process orchestrators are supposed to do is to add this information, is to emit this kind of events whenever particular change happens in the business process. And thanks to this, we also leave ourselves the option to experiment with different orchestrator engines. We may use simple if-else statement if the business process is very easy. We may use finished state machine, ACCA, workflow engine, or whatever we like, as long as we follow the convention. Okay, Bruce asks, who will control the convention? A team will, because team autonomously will be responsible for the product end to end. And the team won't be happy if their business process won't be visible in task list, in report, or in history. The team will take care of it. Good. Bruce has another question. Tell me, how would you implement the orchestrator? And because I'm a big Spring fan, I would suggest using Spring Cloud Stream, which is a library providing abstraction over messaging middlewares, including Kafka, and enabling us to declaratively defining communication channels, topics in our case, as you can see it on the slide. The process orchestrator listens to messages on commands event and on commands topic, and emits events on generic process events topic. And each microservice, business microservice, has also one topic where it listens to commands and one topic to emit events to. And what's more, Spring Cloud Stream has also fantastic support for automatic testing of such communication. It is also supported by Spring Cloud Sleuth in terms of tracing, and it also enables us to make contract tests with Spring Cloud Contracts. So it's an invaluable tool from Spring ecosystem to implement this solution. Bruce is still not satisfied. How do I know that the event emitted from business microservice is dedicated to my business process instance and not to the others? Yet by another convention. This time, each message can be enhanced with a header, regardless if it's a Kafka message header or if it's part of regular payload of the message. This header would contain information that are necessary in order to uniquely identify the business process instance. And this header would be added by process orchestrator to every command. And what business microservice is supposed to do is to take this header and put it back to the event, so that whenever the event occurs and is consumed by the process orchestrator can find out to which business process instance it is related to. Doesn't it sound similar to what Spring Cloud Sleuth does? It's pretty similar. And next question from Bruce. How do I find task list for a particular user? And here comes Kafka Streams. It is a lightweight library built on top of Kafka Consumer and Kafka Producer, and it lets us calculate streams, publish events on other topics, make aggregations, windowing, filtering, and build read models regarding task lists. What we could do is that we could declaratively define how we consume generic process events, how we group them, how we filter them, and finally, how we produce a table for the read model. And actually, this is the way that we are producing read models in Vattenfall every day, and it works like a charm. Does it work the same in terms of reporting? Yes. The reporting module may listen to events of whatever type. It may listen to process orchestrator events. It may listen to events emitted by business microservices, whatever we need in order to create a valuable report. And we can use Kafka Streams and produce some key tables. We can hold our data optimized for reading in Cassandra, in Mongo, in whatever database we like. We may use Spark, Scala, Flink, whatever we know, whatever we like to use. We can use some machine learning. So separating reporting component from all other business process-related components gives us a lot of possibilities. How can Bruce monitor its services? Well, assuming that Bruce read the article from Martin Fowler entitled Microservice Prerequisites, before going to microservices, one of the things that we must provide is basic observability and basic monitoring. And in this area, we have countless possibilities. But if we are around Spring toolset, the very basic tool, the very basic library that you must have is Spring Cloud Sleuth, that lets us trace the route of our business process. Because to every message that is being sent to Kafka, we add a trace ID, a span ID, so that we can very easily find the trace of how the communication looked like. And in order to make it useful, we also need some central place, some central log aggregating system to actually search for this kind of information. And an example could be Elasticsearch logs/Kibana stack. Apart from logs, we could also monitor latencies or latencies between services. And to do it, we may apply Zipkin, which collects traffic samples and analyzes the interdependencies. We could also use Micrometer, Prometheus. We may also take one step further for semantic monitoring and apply tests that run on our production environment and check if our business process works well or not. Remember we said that people are an essential part of microservices? Who should be the owner of the process then? And ideally, as we already mentioned, it would be best if the whole process is managed by one team only. And if the process orchestrator can be matched with business microservices one-to-one, then the problem is gone, because it could be even just one application. Problem is gone. If the business process is a bit more complex and crosses multiple microservices, what we should carefully think is, what is the core business of our process? And around this core domain, we should build our process, and all other stuff should be treated as generic or some supporting subdomains. And this, as we mentioned, should be available to us after event storming session. In our case, the customer contact is the core of our process. So this is the team that is responsible for customer contact that should be responsible for the whole business process as well. And AML and authorization services can be treated as supporting or generic subdomains. Of course, this is just hypothetical discussion. It will depend on our business, on our organizational setup, etc. The other question from Bruce is, where did you get this idea from? I read the book, Enterprise Integration Pattern. Command message, event message, transactional client, event-driven consumer, idempotent receiver, and many, many more patterns that I don't even remember all the names. They were already discovered, and what we did is just we took them and applied them to our solution. So I really recommend you all to read this book. Let's sum things up. In our proposed solution, we still might have common UIs. There are no longer 3 click through some management consoles. They might be written by our front-end developers, and the views won't be common only to our business processes, because they're owned by us, not by any vendor. So it might be common for all systems that we have in our company. Reports, we may have reports that business never dreamt of, and that no vendor will ever give you, because we have the technological autonomy. We may use tools of whatever type we like. Regarding the model, we may use whatever model we like to create some BPMN diagrams, but it doesn't matter. The only model that matters is the one that lands on the wall during event storming session. Do you know why? Because then we start communicating with each other. And this is much more valuable for us than some crazy diagrams written by analysts. Regarding system integration, we no longer need any connectors or stuff. We may use REST template, Feign, we may use web client from Webflux, Spring Cloud Stream, whatever we like to integrate our system with all the others. And instead of having one black box, we'll have numerous black boxes in form of process orchestrators. Does this architecture apply to the idea of autonomous microservices? Let's try to find this out. Thanks to the fact that instead of having one central workflow engine, we have numerous process orchestrators, we may independently deploy each process, so we get deployment independence. Such approach lets us also separate data models. Each business process orchestrator can have its own database, its own schema, protect the data itself, so we get data autonomy. Do we have resilience autonomy? Yes, we do, because the failure of a single business process that does not need to cause the global system failure. Similarly, we can independently scale our processes, so we get scalability autonomy. Separate process orchestrators lets us choose technologies of our choice that are appropriate for the complexity of the problem that we are working on, the complexity of the business process, so we get technological autonomy. Thanks to this, we can also experiment with the work and make our company more competitive. And finally, people. They take care about the process end to end. They're no longer afraid of producing any change, worrying that they will break the whole system at once. And even if their work will depend on the other's team, like for example, we have a business process that depends on the other in the relation of sub-process. We may write contract tests to ensure everything is fine before going live. Small processes, small services mean low level of entry for newcomers, low cost of change, organizational scalability, and this is just a few advantages that we may get after applying this solution. And Bruce is now a happy man. He knows the importance of business processes for his company. He knows the pain points. He knows where the value is. He knows where a company loses reputation when it gains reputation. With event storming, he discovers processes, and thanks to this, he's on the same page with the business. And he drinks coffee with these people. He uses latest technologies appropriate to the complexity of the problem that he's solving, and he applies real autonomous microservices. Microservices autonomous from perspective of scalability, data, technology, resilience, deployment, and people. And you know what? People that left the company are actually willing to come back. Before I say thank you, I would like to really encourage you to take a look at DDD by Examples project called Library that we created together with Jakub Pilimon from Pivotal, which is a comprehensive example showing our step-by-step journey to delivering software solution using big picture event storming, example mapping, design level tactical event storming, including process of choosing the right aggregates, some functional programming as well. So I really recommend you finding us on GitHub. And thank you very much for coming up here. I would be more than happy to get your feedback, so please make your vote in the Devoxx app, and I hope to see you next year. Thank you very much.